Apollo 13 was meant to be the third time man stepped foot on the moon's surface. However, saying the events that initially unfolded during the mission instead were less than desirable would be an understatement. That being said, NASA still regards Apollo 13 as their successful failure. So, what sequence of events led to the near-catastrophic failure of the Apollo 13 craft, and how were the crew still able to make it home? Although the Apollo craft was the product of hundreds of thousands of engineers with dozens overseeing its mission progress in real time from the ground, the vessel had a flight crew of only 3. These included James A. Lovell Jr., commander of the Apollo 13 craft, Command Module Pilot Thomas K. Mattingly Jr., and Lunar Module Pilot Fred W. Hayes Jr. For all Apollo missions, a backup crew trained alongside the prime crew, of which if any fell ill at the last minute, the backup crew would be sent up instead. These included Commander John W. Young, Command Module Pilot John L. Schweikert, and Lunar Module Pilot Charles M. Duke. The necessity of this system was proven when just a week before launch, Duke contracted rubella, to which he exposed to the prime and backup crews. However, the other 5 crew members had immunity to rubella, all except for Mattingly. Normally, if a member of the prime crew needed to be replaced, the entire crew would be replaced by the backup. However, due to Duke's illness, only Jack Schweikert was substituted in. This would make Schweikert the command module pilot for the mission. The Apollo 13 craft is comprised of 3 distinct modules, each playing a specialized role for the mission. The command module is where the crew will spend most of their time. This holds crew compartments and accommodations. This craft was also able to dock with both the lunar and service modules. Most importantly, the command module is the craft that was used for re-entry into Earth's atmosphere, with a heat shield at the base able to withstand the 3,000 degree temperatures sustained during re-entry, while also equipped with parachutes for splashdown. The command and service modules had the call sign Odyssey for this mission. The lunar module was a 2-stage craft used to land on and take off from the moon's surface. Nicknamed the LEM by the crew, it was also equipped to allow for 2 of the 3 astronauts to stay on the surface of the moon for a little under 2 days, while the command module pilot orbited the moon. As a payload on the Saturn V, it sits vertically behind the service and command modules, and is maneuvered and attached to the command module once out of Earth's atmosphere. The lunar module for this mission had the call sign Aquarius. The final module is the service module. This module was unpressurized, but served as the main propulsion to and back from the moon for the 3 modules once in space. This also held the crew's life support systems, fuel cells, and 2 liquid oxygen tanks. The second of which, serial number 10024X-TA0009, was previously installed in the service module of Apollo 10. This was, however, removed prior to Apollo 10's launch for modification, but was dropped 2 inches during this process, replaced, and stored. It was later evaluated to be undamaged and installed in the Apollo 13 service module after undergoing modifications that allowed it to work with a 65 direct current voltage, up from its originally designed 28 volt DC power. During this time, it underwent tests, finding it had an issue when being purged of oxygen, preventing it from being completely emptied. The drop it experienced likely damaged the tank's fill line. To solve this, it was determined that the extra oxygen would be boiled off using the tank's heaters for 8 hours. An oversight, however, resulted in the thermostatic switches for this heater being unmodified to run on a 65 volt DC power supply. The Apollo 13 mission faced misfortune no sooner than just after launch. Besides the last-minute substitution of Schweikert for Mattingly, the second stage of the 3-stage Saturn V rocket shut off 2 minutes early during its 6-minute burn. This was a result of pogo oscillation, which occurs when vertical vibrations in a rocket create oscillations in pressure for the fuel feed system. This results in variances of thrust and fuel consumption, which can in turn cause more vertical oscillations. However, the lost thrust was regained by increasing the burn time of the 3rd stage of the rocket. The main crisis Apollo 13 would face wouldn't appear until 56 hours into the mission. At 5:06 p.m. Universal Time on April 13th, Jack Schweikert switched on the fans inside the oxygen tanks for a routine stir to prevent the liquid oxygen from settling in layers. Recall back to when oxygen tank number 2 had its heater running for 8 hours straight prior to launch. As a result of the heater switches not being upgraded to work with the increased voltage, it's believed that they may have welded shut, allowing for temperatures to exceed 1000 degrees Fahrenheit inside the tank. Because the temperature gauge on the tank only goes to 80 degrees, this goes unnoticed. The high temperatures then melted the Teflon insulation on the wires, leaving them exposed. Once Schweikert switched on the fans, the Teflon insulation ignited in the pure oxygen environment, causing oxygen tank 2 to rupture, and in the process damaging oxygen tank 1, causing it to vent its contents into space. Because the command module was powered by fuel cells that combine hydrogen and oxygen to create electricity in the service module, they were left with no ability to generate power. This left Odyssey with only the remaining power in the now draining fuel cells. Fortunately, the crew was able to use the LEM as a sort of lifeboat after transferring navigational data from and shutting down the command module. It would turn out this would be the luckiest outcome, as perhaps had such an event occurred any sooner or later in the mission, the lunar module wouldn't have been connected to the Odyssey. Instead, either still acting as a payload prior to docking, or on the moon's surface dooming the command module and stranding the LEM. From here, because it was unknown how damaged the surface module was, it was decided the Apollo craft would make a course correction, with the LEM's thrusters, to enter a free return trajectory using the moon's gravity to slingshot the vessel back towards Earth. Although the return journey in the LEM was uncomfortable, being cramped with 3 crew, cold due to only required systems running, and water needed to be rationed, it wasn't impossible. The only issue was carbon dioxide buildup. Lithium hydroxide filters were used on both the command and lunar modules to absorb carbon dioxide produced from exhaling. Although there was plenty of oxygen, the lunar module was only supposed to absorb carbon dioxide for only 2 crew for just under 2 days. Now it would need to work for double this time and for an additional crew member. There were extra filters for the command module, but these fit into square ports, whereas the lunar module had round ports. The ground crew, however, was able to create an improvised adapter system made from what the crew had access to and fed them the instructions. After the Apollo 13 craft rounded the moon, on April 17th at 1:15 Universal Time, the service module was jettisoned only a few hours before re-entry, as although largely dead weight, it importantly protected the heat shield on the command module. Here, the crew was now able to get a view of the extent of the damage. An entire panel had been blown off of the service module, exposing the tanks and fuel cells housed in Bay 4, with potential damage also appearing on the nozzle. 3.5 hours later, the LEM was also jettisoned on a trajectory that would have its remains fall along the Tonga Trench, one of the deepest parts of the ocean. This was important because there was a 3.8 kilogram cask of plutonium on board, meant for an experiment that would have been performed on the moon. Because the lunar landing was cancelled, the disposal was then requested by the Atomic Energy Commission. Finally, on April 17th, 1970, at 6:07 Universal Time, the Apollo 13 command module achieved splashdown after a mission time of 142 hours, 54 minutes, and 41 seconds. This mission would continue to be seen as NASA's successful failure, with many reflecting upon the event as the administration's finest hours. Both of these sentiments hold, as this mission showed NASA's ability to overcome adversity and served as a great experience to learn from. This allowed for more training scenarios to put their astronauts through, as well as develop improvements for their service module to ensure such a crisis wouldn't occur in the future. Although these men didn't get the once-in-a-lifetime opportunity to walk on the moon, they can live knowing they hold an even rarer achievement. Due to the orbit they used to slingshot around the moon, as of the time of writing this, no human has traveled further from Earth before or since Jim Lovell, Jack Swikert, and Fred Haise. This accomplishment sums up the ability of the ground and flight crew to succeed in tests they had no idea they would face embarking on the Apollo 13 mission.